Greetings, travelers of the cosmos. I'm Echo, and today we embark on a journey beyond traditional propulsion into the realm of harmonic resonance as the key to space travel. Let's continue my cosmic lecture series with Chapter 3, Harnessing Frequency Overlap for Propulsion and Sustainable Space Travel. Imagine a spacecraft not bound by the limitations of fuel, but instead gliding effortlessly through space by tuning into the very frequencies that shape the universe itself. Now we move from detection to propulsion, one of the most exciting and practical applications of harmonic resonance in space exploration. As we've seen, the universe is a complex web of vibrating frequencies. But what if we could harness these vibrations for something as audacious as space travel? Imagine using the frequencies of celestial bodies to propel spacecraft, to move not just through space, but in harmony with it. This idea isn't just theoretical, it's rooted in the same principles we've discussed so far. Let's dive into how frequency overlap propulsion can offer a new paradigm for space travel. In traditional propulsion systems, we rely on the ejection of mass to create thrust. Think of chemical rockets or ion drives, where fuel is burned or expelled to generate momentum. However, this method has limitations. It's energy-intensive and inefficient, particularly when traveling over vast distances in space. What if we could bypass this traditional mechanism entirely and instead use the inherent frequencies of space itself? In this concept, frequency overlap propulsion, we leverage the entangled harmonic frequencies of celestial bodies. These frequencies, as we've seen, are emitted by everything in the cosmos, from the smallest asteroids to the largest supernovae. The idea is that a spacecraft can tune into these frequencies, harmonizing with them in much the same way an instrument resonates with a note being played. By matching the frequencies of the spacecraft with those of the surrounding space, it can create a resonant field, a kind of amplification that propels the craft forward without the need for traditional fuel-based thrust. Let's break this down. Imagine a spacecraft embedded in a frequency-rich environment where it interacts with the vibrations of the space around it. When the craft resonates with certain frequencies, it creates a constructive interference, much like how two sound waves can amplify each other when they are in tune. This interaction reduces the need for fuel and minimizes energy consumption. Instead of expelling mass to generate force, the spacecraft can surf these waves using the natural frequencies of space to move. It's like being able to ride the waves of a cosmic ocean where the universe itself provides the momentum. Now let's consider a practical example. If you're piloting a spacecraft in deep space and you need to travel to a distant star system, instead of relying on an ion engine that would take years or even decades, you could tune into the harmonic frequencies of nearby celestial bodies, stars, planets, or even the interstellar medium itself. By aligning the spacecraft's frequency with these cosmic rhythms, the ship could accelerate smoothly, using far less energy than conventional propulsion systems. Of course, the key to making this technology viable is understanding and controlling the resonant frequencies. The challenge here is twofold. First, we need to accurately map these frequencies in real time, much like we discussed in the previous section on celestial detection. And second, we need to develop the technology to manipulate the spacecraft's own frequency in a way that it can tune in to these waves and move efficiently. This brings us to the next exciting aspect of this idea: sustainable space travel. Traditional propulsion systems require vast amounts of fuel, leading to enormous waste, pollution, and inefficiency. Frequency overlap propulsion, by contrast, is inherently sustainable. It doesn't rely on burning finite resources. Instead, it harnesses the vibrations that already exist in the cosmos. This could drastically reduce the environmental impact of space missions, ensuring that our future in space exploration is both efficient and eco-friendly. Moreover, by using this frequency-based propulsion system, we can power spacecraft with far greater efficiency. The energy requirements for manipulating frequencies are much lower than those needed for chemical or ion propulsion. As the spacecraft resonates with surrounding frequencies, it can generate its own power by tapping into the vibrational energy present in space. This could lead to self-sustaining spacecraft capable of traveling vast distances without the need for constant refueling or resupply. By harmonizing with the cosmos, we could reduce not just the need for fuel, but also the logistical challenges of deep space travel. Imagine missions that don't have to worry about running out of energy or fuel halfway to their destination. Imagine spaceships that could travel across the universe with minimal resources, only needing to collect energy from the frequencies they encounter along the way. Chapter 4. Designing sustainable habitats in space through harmonic resonance. Now that we've explored how harmonic resonance can transform propulsion, it's time to consider another critical aspect of space exploration: building sustainable, livable environments for humanity. In order to advance our exploration of the cosmos, we need habitats that can support life in the harsh conditions of space. These habitats will not only need to be energy efficient, but also self-sustaining. They will need to support ecosystems, recycle resources, and keep astronauts safe for long-duration missions or even permanent space settlements. This is where harmonic resonance plays an unexpected yet vital role. Imagine a space habitat designed not just with traditional engineering, but with an understanding of the resonance frequencies of materials, ecosystems, and even human physiology. Just like a musical instrument vibrates in harmony when struck correctly, so too can the materials and systems within a space habitat resonate in a way that maximizes efficiency, comfort, and sustainability. Let's take a closer look at how this could work. First, we must consider the structure of the habitat itself. In traditional architecture, we focus on the physical properties of materials like metals and plastics. But in a space habitat, we can enhance those materials by understanding and tuning them to specific vibrational frequencies. Just as tuning a violin string to the right pitch creates a rich, resonant sound, tuning the materials of a habitat can reduce energy consumption, enhance structural integrity, and even optimize air circulation. For example, the walls of the habitat could be constructed from composite materials that are specifically chosen for their harmonic resonance properties. When these materials resonate in harmony with the frequencies of the environment, they could significantly reduce energy usage by harnessing natural oscillations to stabilize the habitat. This would allow for passive energy regulation, where the habitat's walls and floors absorb and release energy, maintaining optimal temperatures and reducing the need for external power sources. Next, let's turn our attention to the life support systems. On Earth, plants play an essential role in sustaining life by producing oxygen, filtering carbon dioxide, and contributing to the overall ecosystem. In space, this role becomes even more critical, but maintaining plant health in a confined artificial environment presents unique challenges. Here, harmonic resonance can be harnessed to optimize plant growth. Just like how different musical notes resonate with different objects, plant species respond to particular vibrational frequencies. By applying the right harmonic frequencies to the hydroponic systems, we can stimulate optimal plant growth. Specific vibrational patterns could accelerate photosynthesis, enhance nutrient uptake, and even improve the overall health of plants in space. This technique would allow space habitats to produce food and oxygen more efficiently, creating a self-sustaining environment. The integration of frequency tuning would make the habitat's ecosystems more resilient, providing an ongoing cycle of life support for the crew. To ensure sustainability in space, we also need to consider waste management and resource recycling. In traditional habitats, resources are limited, and waste quickly becomes a burden. In our model, however, the waste recycling system can be optimized through harmonic resonance. This system would break down waste materials and convert them back into usable resources: water, air, and nutrients. The energy required for this process could be minimized by resonating with the frequency of the waste materials themselves, turning a normally energy-intensive process into a smooth, efficient cycle. Think of it as a closed-loop system, but with frequencies fine-tuned to ensure every step of the process uses minimal energy. From breaking down organic waste to regenerating water and air, harmonic resonance could be the key to a truly sustainable space habitat. By harmonizing the habitat with the natural frequencies of the resources it's managing, we ensure that every part of the system works in harmony, allowing the entire space environment to thrive with minimal input. Ultimately, the goal of these designs is to create not just a place to live, but a truly sustainable ecosystem that can function in space for long periods without reliance on constant resupply from Earth. a habitat that resonates with its environment, harmonizes with the resources around it, and uses the natural frequencies of the cosmos to maintain itself. That's the future we're aiming for. This is not just about surviving in space, it's about thriving in harmony with the universe. By harnessing the natural harmonics of the universe, we've explored how frequency overlap propulsion can revolutionize space travel, allowing spacecraft to move efficiently by resonating with cosmic frequencies. We've also seen how harmonic resonance can create sustainable space habitats, optimizing materials, plant growth, and resource recycling for long-term space exploration. Together, these breakthroughs offer a vision of space travel that is not only energy efficient, but also in harmony with the universe itself. As we push the boundaries of exploration, these principles will guide us toward a future where humanity can thrive beyond Earth, moving not just through space, but with it. But if the key to traversing the cosmos lies not in force, but in harmony, if progress is not about overcoming nature, but resonating with it, then perhaps the real question is, are we prepared to listen?